Okay, in real life, we very rarely have population data. Normally what we have is sample data. Here's an example. I've got a sample here. This is taken from a population, and we know about this that it's got a mean of 71.5 and a median of 51.5. Right? But that, and at the moment, that's all we can say about our population. But every time we take another sample, we'll get a different mean and median. Look at this. Here we go. We'll take another sample. Right, now it's 75 and 60. We've got 77 and 57. Every time we take a sample, we get a different mean and a different median. They're similar, but they're different. And so what that means is that we can't tell too much about the population based just on the sample, particularly this sample, because it's only of 20, which is a really small sample. But we can't tell too much about the population. We need to use some sort of method to do it. And so that's why we use bootstrapping. Now, to put that in context, let's have a look at what it looks like with the population data in there as well. See, unlike in real life, we actually have population data here. We can see all the population as well as seeing our sample. And so what we see here is that we've got, our population has sort of two groups of data. There's this group here, which is most of the data, about 75% of it, and it's all clumped up here. Over here we have another group that's wider, right, and is this group here is more spread out. About 25% of our data is much higher. And so because of that, depending on how much of this group gets picked, will make a big difference to what our mean is on our sample. So here we see in this one here we've got 5, which is about right. We've got about a quarter of them picked, right? So this one's worked out reasonably close. And if we look up here, because of that, we end up our mean and our sample, our population, our sample are actually really, really similar, right? But if we take another couple of samples, right, we see with this one here, we've now got 2, 4, 6, 7 from the high group, maybe 8. That one might be the bottom of the high group or the top of this low group. And so because of that, our mean is now, I've got these two around the wrong way, sorry, the mean's the bottom one. Our mean is now 82.95, quite a lot higher than the population mean. The median is still about the same, because the median doesn't get affected by outliers as much. But what it does mean is that we can't tell, just from looking at our sample, too much about the population. That's why we need to use either a confidence interval that's created through parametric statistics, or a confidence interval that's done through an informal confidence interval with interquartile ranges, or else a formal confidence interval done with bootstrap. We have to use some sort of technique like that to be able to talk about the population, because every time we take a sample it's different. Now with a larger sample, that variation is going to be smaller, but it's still going to happen. And that is why we use bootstrapping. So that's what we need to talk about in our assignments. When we're talking about why we've used a bootstrap, it's because every time we take a sample, we get a different result. And so what we can tell from our sample is only our sample until we use a technique. That's why we use bootstrapping.